So far, new things that we have learned is delta y is finite change in y, dy is very small change in y, and if I write delta y by delta x, that would mean average rate of change of y with respect to x, and dy by dx is nothing but instantaneous rate of change of y with respect to x. Let's explore dy by dx in more detail, which is also known as differentiation of y with respect to x. Differentiation of y with respect to x is nothing but instantaneous rate of change of y with respect to x, which is also represented by dy by dx, which was in turn obtained from average rate of change of y with respect to x after shrinking delta x, which is equal to limit delta x tends to 0 delta y by delta x. This equation dy by dx is equal to limit delta x tends to 0 delta y by delta x tells you that the instantaneous rate of change of y with respect to x is obtained as average rate of change of y with respect to x given this condition that delta x tends to 0, or the observation is taken very near to the point. Given this definition, let's try to find out dy by dx of a function. For example, we have a function y equal to x square, and we wish to find out dy by dx, which is instantaneous rate of change of y with respect to x. As the definition says, it will be limit delta x tends to 0 delta y by delta x. So our target first is to find delta y by delta x. So let's see what happens when x changes. Let's say x changes from x plus delta x. The value of the function at x, y at x, let's say that is y1, is simply x square. Now, the changed value of y at x is equal to x plus delta x, let's call that y2, is equal to x plus delta x whole square, because the value of x is x plus delta x and we have to substitute x plus delta x in place of x. Now that delta y comes out to be y2 minus y1. This is equal to x plus delta x whole square minus x square. If you expand this term, you will see x square will cancel out and the answer will be delta x whole square plus 2x delta x. The next step is to find delta y by delta x. So what is delta y by delta x? It will be simply here for this function delta x square plus 2x delta x divided by delta x. If you take delta x common from the numerator, then this delta x will cancel out and the answer would be delta x plus 2x. Now let's try to evaluate dy by dx from this. So dy by dx is nothing but the evaluation of dy by dx under the condition that delta x tends to 0, which is represented by a limit delta x tends to 0 delta y by delta x. So let's substitute the value of delta y by delta x under this limit. It is limit delta x tends to 0. We'll have delta x plus 2x substituted in place of delta y by delta x. And you can quite clearly see that if delta x is very small, which is very close to 0 but not 0, so very small number added to a finite number, which is 2x at certain point. So a small number added to a finite number will be as good as 2x. We can neglect delta x as it is very small and the answer would be 2x only. D by dx of a function y equal to x square, here y is equal to x square, dy by dx or dy by dx of x square is nothing but just 2x. So that would be the formula for dy by dx of x square.